Hello, everybody. We're going to present MRAT, the Mixed Reality Analytics Toolkit. And so this is work done with a number of colleagues and students at the University of Michigan. I'm Mike Enabling.
I'm Shweta Rajaram.
Right, so we are two of the authors on this work, and this work started actually a long time ago at Michigan, involving Maximilian Speicher in particular. And so this work started out with this vision and also a question, like, what if we wanted to do user studies in mixed reality, for example, involving devices like Hololens? And we had this idea of bringing in lots of easy ways of constructing user studies. We had this idea of bringing in physical markers so that they can actually guide participants through tasks. And then obviously we can see these markers as well on HoloLens, and we can recognize which tasks participants are working on. We can establish metrics whether they are successful or not. So those are the key ideas behind this work, and the contributions of this paper specifically are this requirements elicitation that we conducted with 8 university research instructional media teams, all working on XR projects. We present the design of the toolkit. We wanted it to be as generic as possible. We demonstrate that MRAT can actually be used on a number of existing MR apps. We wanted it to be the system to be flexible and easy for users, including researchers like us, to define tasks and metrics for data collection. We also wanted to support the usage of HoloLens, for example, the device that you're actually using to collect data. But we also felt like we needed part of the interface to be run on a second device. So there's a tablet that we'll show later, helps you during data analysis tasks and visualization tasks. The paper also presents, and this is where Shweta is going to help me a lot, presenting this part of the paper is the MRAT crisis case study. So we really wanted to test out our toolkit, and we had this challenge with publishing this toolkit, and so we added this case study that now shows how we could use MRAT, and other researchers could use MRAT to design a mixed reality world and maybe do optimizations around it. We also demonstrated this for a specific crisis simulation class exercise, where we transformed a physical classroom into a mixed reality experience. We show, as I said, how MRAT supported performance tuning and data collection and analysis. Okay, if you look at related work, there is a lot of work in the toolkits space that MRAT adds to. So previous toolkits were initially focused around web, and then mobile, and then touch and multi-touch, and then there was a stream of research around Kinect. So here we pick 2 examples from that stream of research. So Chronovis and Kinect Analysis are both tools that allow experimenters to collect data with these more advanced sensors than just cameras, and they support tasks that go beyond video analysis. So Chronovis, you were able to actually annotate and analyze multiple streams of data. Kinect Analysis was very focused on Kinect, so you had skeletal data, RGB data, and speech commands. And so these tools were designed to support evaluators, often collecting essentially data around how users operate interfaces. And we wanted MRAT to be such a system where we can collect similar data and visualize it in similar ways when it's actually about mixed reality, so both virtual reality and augmented reality interfaces and apps being used. So a lot of researchers currently have to build these tools themselves. Here's one example that Shweta is going to talk about.
Another area of research that we looked into was training simulation. So in this example, the research team created a triage training system that helped participants track their progress. So they got a visualization of their results at the end with how many labels they got correct for the triaging component. So we see in a lot of these works, the researchers are creating their own systems of data collection. So one of the primary reasons that we created MRAT was to simplify this process.
Right, so this triage training system is inspiring in particular for our case study, which we'll present later. But we wanted MRAT to be a more generic tool. So the way we went about it was talking to 8 research, media, instructional teams, really analyzing their requirements. They were all working on a variety of XR projects. So we found that in particular, there's a need beyond usability testing. A lot of the questions they had, what they wanted to find out by doing studies in mixed reality, were not whether this interface is usable or whether this button is sized the right way. So the questions were often more like about user behavior, about other more relevant questions for VR regarding presence. and immersion. There was a strong need for both quantitative and spatial data, so time on task, obviously, but also like how people navigate a scene, where they spend most of their time, what they look at was really important to collect this data. The research team had really diverse requirements regarding interactions, both gesture and speech, but sometimes also just mostly implicit camera-based interactions. Also marker-based interactions were of particular importance to a lot of the research teams. So MRAT should be able to support each of these and make it very flexible. What we also found was that there was really a need for being able to flexibly define tasks. So what a granularity or a unit of a task was very different between teams, and the teams were also experimenting a lot with their study designs. They didn't want to have to program a lot to be able to define tasks, so we had to pay attention in MRAT to make that easy for them. And then the last important finding from our interviews was that there was a need for metrics, but not really commonly agreed on metrics other than time on task. That would help assess performance of users. And so MRAT should really be able to collect a lot of data, and then based on that data, specific to each project, the researchers wanted to be able to define their own key performance indicators. And I feel like we have relatively good support for the first 4 requirements, and there is more work that needs to be done on the last requirement, but it is an important requirement. All right, and here is one of the things you would see when you try out MRAT is a dashboard that shows all the data that can be collected. Shweta, give us a quick rundown.
Sure. So first on the left, number 1, you can see the different users that are currently logging data to the system, different modes of the application. So for our case study, we had a training mode, and then when the simulation started, we had different modes as well. There's also a list of all of the events that are being tracked at the moment, and you can toggle them on and off to simplify the view of the dashboard. And then number 2, if you hover over an event with your mouse or click on it on a tablet, you can see some more detail. So for this event, we have a photo that was sent through a message. We can see which user sent the message. We can see the time that it took place as well. And then 3 on the right side, we have a spatial layout of the entire room. So you can see where the participants moved during our study. You can see other objects that are being tracked, such as a timer and windows in the room.
We also have this support for actually visualizing the data in mixed reality. And that's something we spend quite a bit of time on optimizing and getting to work on HoloLens. So here we see a little video of what that looks like. So this is a first-person view. You see a lot of data that was previously collected. This is from our MRAT crisis test runs, so not the actual study, but some test runs in the lab. And then you are able to inspect that data in situ. So you can actually go back. You use the tablet here as a device for filtering, but you can still interact with the data using HoloLens. So we have some interactive clustering techniques that make sure that not all the events are visible all the time. And we can really navigate and filter the data based on interactions on the tablet, which we show here, but also just you walking in that room really determines which events are actually visible or not. So we have step-by-step playback, a couple of basic interactions. We have event-based filtering. So if you're looking for a specific event, so for example, when injuries occurred, which we'll talk about later, where they occurred, who was injured, where people were in the room at the time, you can do these kinds of spatial queries. So one of the things you have to imagine a lot, but we don't show in this video, is how you use MRAT. So MRAT is implemented right now on top of Unity, a lot of the components of MRAT. So we provide various editors that allow you to configure tasks relatively flexibly and quickly without programming, but you do need to have a basic understanding of Unity. Okay, let's talk a little bit more about the MRAT crisis case study. That's really a big part of the paper.
So our case study was designed for a crisis informatics course here at the School of Information for master's students. And a key component of this course is completing a collaborative lab at the beginning and the end of the semester, where the students are given a crisis situation. So in this case, they were in a safe house during a civil war, and their object was to survey the situation to see what supplies they had to treat anyone that got injured within the simulation, and also send a runner to a remote headquarters location when it was safe during the simulation. So this is our floor plan that we made after actually observing the simulation run at the beginning of the semester.
And we also went through this triage training exercise. That was, here you see some members of our research team. We have somebody who's a professional in nursing, and we were running through this triage training exercise using Lego figures to simulate patients and making key decisions how to solve a disaster where I think there was a train crash and several people were injured. And it was an interesting experience for us as a research team to get a better sense of crisis simulation and which of these components might translate how to mixed reality. And so we started prototyping, and Shweta is going to walk us through some of the features that came out in the end, but this is a previs essentially of what we wanted to do. So this is the room in which our study will take place. It is a safe house, but it's a little bit destroyed. It's in a war zone. There's fire, electricity there. People get injured. It's an escape room simulation. You have to wait for the right moment to actually leave that room.
And here is the Unity version of the mixed reality application. So you can see there's a timer on the wall. There are several windows, and you can see outside the windows to see the civil war going on. There are a few dead bodies in the room to kind of increase the anxiety, I guess, or like the stress of the situation. And then here is the application running on the HoloLens. So
yeah, we see unfortunately some dead people in our room using HoloLens, and we show other parts of the system as well. I got injured, and I think Lucy and Shweta are trying to triage me. So triaging is it follows a specific protocol and assessment that we learned about and actually implemented in mixed reality. Right, there's phones in the simulation as well, and t-shirts to project wounds. And so it's really a complex little case study that involved various components. But the purpose or the focus of this, for the purpose of this paper, is really the use of MRAT throughout this case study.
So here you see the user study taking place. You can't see the mixed reality content, but the players are kind of surveying the environment. They're seeing the windows. They're seeing the dead bodies. They're kind of warning each other to stay out of danger's way. Right now they're performing triage, completing the injury task, sending pictures and messages with the players' injuries. And throughout this entire time, MRAT is collecting data about where they're moving in the room. They're collecting data about when the runner left the room. So here's actually the session that we recorded. So one key aspect of the simulation that we wanted to improve using MRAT was performance. We had some issues with frame rate at the beginning with, like the explosions happening in the room. So we used MRAT to tune performance and kind of lead us to the design decision to put a lot of the virtual objects outside of windows where they don't always have to be rendered.
Yes, and that also makes a lot of sense given the small field of view of a HoloLens. We also played around with different t-shirt designs and making it possible to kind of like accurately, anatomically accurately place injuries, different types of injuries, and support the triage tasks. We played around a lot with marker tracking performance, and we discussed this in detail in the paper as well. Different types of t-shirt designs, black versus white, how does it react to light? And we checked how well and reliable would the marker tracking work using a combination of Vuforia and HoloLens. All right, so we hope you enjoyed watching this video, and please read the paper. We believe the main takeaways from this paper were really how we approached this whole task of designing a toolkit like that, how we took into account the different requirements by talking to these diverse teams. We discussed in detail in the paper how we designed the analytics part of the toolkit, supporting data collection, data playback, using this combination of the tablet and the HoloLens rather than doing everything in mixed reality. So no minority report from us. And we also, the parts that Shweta expanded on a lot was this case study that really showed how we could use MRAT both to run user studies with it and then also to optimize the experience. So again, this was the Mixed Reality Analytics Toolkit MRAT. Well, involved a lot of students in particular. So thanks to all of these guys. We also got a best paper on that, so we were very happy, and we're so sad we couldn't see you guys at Kai. And if anybody watches this video, please drop us a note.